Hello everyone, I hope you're doing well. Today I'm going to talk about one-way ANOVA test, its requirements and when we should use it and how do the test in Spss. Imagine that in a medical clinic, they conduct a study about the techniques helpful in lowering the blood pressure in a sample of patients. In this regard, they use 3 techniques named medication, exercise, and diet. The goal here is to find out which technique is the best, or is there any significant difference between these techniques in the process of lowering the blood pressure or not. To do so, they conduct these techniques on a sample of 15 patients in total and randomly dedicated 5 patients to each of these techniques. Let's start by entering and defining variables and data in Spss. As you can see, I've done it already. So here we have 2 variables, one techniques or groups, and the other one blood pressure level. For variable techniques, we need to label each of them to conduct the test. Here, as you can see, I defined 1 as medication, 2 as exercise, and 3 as diet. And this variable is nominal. And the blood pressure level is a scale variable, and we can define the label for it to get the whole name. So write blood pressure level. So here are our data sets. Enter the techniques in order, and then the blood pressure level corresponding to the technique used for each specific patient. And by clicking on this button, which has number 1 and letter A on it, you can switch between the labels and their values. So we are ready to conduct one-way ANOVA. To do so, go to Analyze, Compare Means, One-way ANOVA. And now we can see variables label. By right-clicking and choosing variable name, you'll see the name instead of the labels. So the dependent variable is the scale variable, which is blood pressure here. Put it in the box by clicking this arrow. And factor is the categorical variable, which is techniques. So put it in the box named factor. And now click on post hoc. We have 18 tests for assumption of equality of variances. But for same number of participants, we will select 2 key. However, we'll need to check our assumptions for ANOVA if we ended up with unequal variances. And we'll need to use the test game Howell post hoc. And just click continue. Now click on options and select descriptive to get the means and standard deviation. And select homogeneity of variance test as well for Levin's tests. And also select Welch in case we find that the assumptions violated. And also the means plot so that we can see the line graph of the means. So click continue and then OK. We can see the results. And the first table contains standard deviation and mean. This contains mean and standard deviation of each of them, confidence interval, and the minimum and maximum value of each technique. And the second table gives us the results of homogeneity of variances. As you can see, the p-value amount based on mean is 0.659, which is not close to 0.05. We have done this by the Levene's test, which tests the variances of two groups or more are equal or not. It doesn't mean that they are precisely equal, just close enough. This in our test, this means that we'll not need the Welch and Game-Howell post hoc tests neither. So, move on to the third table. The third table is the F table. It gives us 7 results to interpret. We'll use F followed by degrees of freedom between and within, which are 2 and 12. And the F value is 3.311. And we'll need to look up critical F to compare these two. You'll see the F table here, and our critical F value here with degree of freedoms of 2 and 12 is 3.89, which is larger than our F value, which was 3.311. So we will not reject the test. Next is the p-value, which is 0.072, and it is greater than 0.05. So the next table is Welch's robust tests for equality of mean. Here, because variances are not different, we don't need this result, and you can just ignore it. If the Levene's test was significant, then you will need that. And the same logic applies for Game-Howell post hoc test. And the sixth table is the post hoc test's result. None of our treatments or techniques are different from the other one. None of the p-values are less than 0.05. So they are not different. And also all confidence intervals cross the zero. So they will not reject the null hypothesis. We could continue these comparisons, or we could evaluate the homogeneous subsets. SPSS will create subsets for groups that they are the same as each other. But for our data set, since none of our treatments involve in one subset, we don't need this table. It means that none of these groups make a subset alongside with the other one to be different from the remained one. So here is our results. There is not a significant difference among the 3 techniques on blood pressure levels, meaning that they were all helpful approximately to the same extent. And that's it. Thank you so much for watching this video. In the next videos, we'll continue talking about other forms of ANOVA.